right, so as promised during our last class, I was going to go over some, I kind of rushed the ending of comparing the regressions of simple and compound interest. So I wanted to graph them kind of on a bigger scale. So I usually tell people don't do this in my graphing classes. You should always start with 0 and work up your scale. But just for the purposes of being able to see these regressions a little bit closer, as you can see, I put a little thing here that identifies that there is a big graph and where our graph starts and where it should be scaled, okay? So if you were in any of my graphing or data type classes, I tell you this is a no-no, but I'm only doing it to show you this regression. So what I have here is simple. I'm putting the simple in red. Okay, and this is the time down here, and this is the yield, the amount of money we get out of the investment. All right, and if I were to connect all these dots, you'll see, and I'm not the best at this, so give me a break on it. You'll see it makes a straight line. That is because simple is linear. Okay, and some characteristics of this is I could predict where the next point is going to be because each one of these points are going to share the same distance. If you know anything about linear lines, you know that means slope. So in the x direction, I'm going from 10 to 15. It has 5, and from this one, I'm going from, was it 1950 to 2175. So I could figure that out what the slope is of this line fairly easily. It's 225. So the slope of this line is my y over my x, which is 225 over 5, which equals 45. So I can see that the slope of a linear line every single time I move on this line, I'm going to be moving 45. Okay, I'm going to be moving an amount of 45. That is in a simple interest formula. That is actually my interest. I'm gaining interest each time I compound interest. I'm always going to compound the same amount. I'm going to compound 45. So these are some things about a linear line. We can always predict what it's going to do. Exponential is not the same because remember, we don't always have the same amount of interest. We're always compiling because what we do is we take our principal, we add the interest we've already earned to the principal, and then we do the interest again off of that new amount. So the amount that we're collecting the interest from is always changing, whereas it doesn't do that with simple. So in the beginning, before we accrued some interest, we're going to look like simple, because we're always accruing the same amount of interest until we hit the mark where we start adding in that interest to our principal, and that amount that we're actually collecting interest from keeps getting bigger. So let me pause and I'm going to put up the next line and we'll compare them. All right, so here you'll see that I added in the dots, and as you can see, we're almost identical in the beginning. Okay, almost an identical line. And then around 5 years, we're just kind of getting ahead. And then at 10 years, we're a little bit higher. And then at 15 years, we are a little bit further away. And then we zoom and take off. And actually, if we kept figuring this out, this is just going to go rapidly at this point. Okay, if we figured out what 25 years would be, and actually, let's go ahead and do that. So hold on a minute, $1,500 times 1 plus the rate divided by the n, which is annually in this one, raised to the 1 times, let's do 25 years. At 25 years, we're going to be well above this. We're going to be somewhere about here. So our 25 mark is going to go all the way we are just going to keep rapidly growing and growing and growing in this exponential regression. So an exponential, that line just got really badly drawn, but you get the point. An exponential regression. Okay, we have two different types. We have a growth and decay. When we're talking about compound interest, we're always working in a growth. So I just want to clarify that this is a growth. Okay, we're growing in money. We're not losing money. If you want to learn more about that, about some of the nuances of that, take my function family class, my Discovering Functions function family. But with a compound interest growth, exponential growth, we don't have a consistent slope. The slope is always changing. And that makes sense because our slope in these formulas, in the simple versus the compound, is our interest, is the interest that we're earning on these accounts. And that is always changing in compound because the amount that the interest is being collected on, that principal amount, is always changing, because what that formula does is it takes the interest from the line before and it throws it into, it adds it with the principal, and then it does it again, and then it takes that, adds it to the principal. So that principal amount that we're figuring out our interest on is always growing. And that is, sorry, my daughter came into the room. That is our slope. So that is why the slope all of a sudden just takes off in an exponential growth, because it is changing and it's getting bigger and bigger and bigger and bigger and bigger each time we calculate it. Okay, so if you want to learn more about different functions, a compound is an exponential function, simple is a linear function, or you can call it a regression. Usually in finance we call it a regression. It's an exponential regression or growth, and it's a linear regression. But if you want to learn more about how these graphs affect the equations, affect what they do, affect what this means in real life, I suggest you take Discovering Function Families. If you felt in this class that some of the things were difficult when it came to exponents, you may want to take one of my exponents class. I have a number of different types. I have perfect square and square roots, and I also have one that deals with the rules of exponents and polynomials, kind of getting you ready for logarithms. Actually, the next point in understanding simple versus compound is to learn how to apply logarithms to it, so we can figure out how long we have to keep our investment into a compound interest investment in order to get the yield we want. Okay, to be able to do that, you need to know how to solve logarithmic formulas. All right, well, I hope you enjoyed this class. I hope you learned a lot between compound and simple interest. If you need any help going further, let me know. If you want to do an evaluation so you can be placed in the correct class, I do them for free. Just contact me and I can do that for you. All right, see you guys in more OutSchool classes.